Hello, everyone. My name is Leonid Yurganov. My last affiliation, University of Maryland, Baltimore County. I appreciate participation of Guido van der Werf. He helped me with the FED. And I will be talking about Canadian Siberian megafires as was measured from MOPITT and other sounders. Measurements of CO. Main points are CO total column concentrations, XCO in ppb, was for three instruments, MOPITT, ERS, and TRAPOMI. And TRAPOMI will be considered. These concentrations are converted in fire emission for high northern hemisphere, coupling of TRAPOMI and ERS data for Canada will be considered, and special attention for fire emission in permafrost zones of both hemispheres. Missing fuel for fires, this question also will be under consideration. Three instruments, ERS, MOPITT, and TRAPOMI. First two are thermal infrared, measuring near 4.6 micron fundamental band of CO. And TRAPOMI is solar light. For TRAPOMI, solar light in the near infrared range, spectral range, was used. CO concentrations from first two instruments were converted into emission rates using a box model. One of the next slides. Independent estimate of emission in the same box was made using Global Fire Emission Database, GFED, by van der Werf and his colleague. That technique is based on burned areas recalculated into emission. Box model is very simple. Two boxes, high northern hemisphere and low northern hemisphere. CO emission is balanced by sinks removal, photochemical removal to CO2, and exchange with low northern hemisphere. The box is between 30 degrees and pole, and low northern hemisphere between equator and 30 degrees. For details, you may see our paper recently published. Averaging kernels of thermal infrared and near infrared instrument are very different. Thermal infrared instruments are most sensitive to the mid-troposphere up to tropopause, and in the lower layers of the atmosphere, sensitivity drops down. Near infrared has another problems. They depend on cloud fraction, and only for low cloudiness, less than 0.3 cloud fraction, this three lines, the sensitivity is high. So after specific filtering, this other cases, it's a very reliable technique. Roughly speaking, we can say that AIRS or MOPITT measures mean free tropospheric mixing ratio, but TROPOMI measures for ideal situations total column mean CO concentration. So the coupling of these two instruments is very fruitful. And you understand that if both instruments give us the same values, that means the troposphere is well mixed, no polluted layer. MOPITT MOPITT data were compared with two other instruments, with EAS and TROPOMI. Two, even three maps you see for global, not for global, for high northern hemisphere, for 2021 August. This is a period of mega fire in Siberia. You see the central part of this fire here, for example. And for us, the situation, the picture for outside fire is good, but for fire, the difference is significant. This difference can be seen from here. This is S points plotted versus MOPITT. So MOPITT values for fire for this area are significantly higher than S, two times higher. But MOPITT data in turn less sensitive to the surface layer than TROPOMI. In TROPOMI, we see the same color scales up to 220 and above 220. All the points are red, off scale. So coming back to here, to this scatter plot, we see that this lots of data are for TROPOMI concentrations are significantly higher than supplied by MOPITT. This one and two other slides illustrate advantages of coupling TROPOMI and EAS and other instruments of these two different techniques. You see two maps for TROPOMI and EAS for the same months of 2024 August. And you see that XCO for TROPOMI for Canada was significantly higher than EAS. Contours are for 120 ppb, and the color scales between 50 and 350. This one, the third map, is for ratio of TROPOMI to EAS. As a result of this comparison, we can say that for this special example, low troposphere is highly impacted by smoldering or any other low temperature burning. But mid-troposphere is moderately moderately polluted. And this, in this case, may be characterized as moderate fire. Next example is again for Canada, for Canadian strong fire of 2023. And Tropomi recorded high values, and AIRS also recorded high values. That means that both boundary layer and free troposphere were equally polluted. And this also can be derived from ratio of Tropomi to AIRS. It is for most of the area close to unity. And convection, probably you may see convection cells here played very important role. So, but anyway, this fire can be characterized as severe fire. The third example is quite different from first two. This is for 2021 August, and during this period of time, the mega fire in Siberia was burning, and this CO measured by Tropomi and AIRS practically very close picture to one to another is not Canadian CO. This is Siberian CO. And on the long range way, atmosphere mixed, and this is demonstrated also by very low ratio of Tropomi to AIRS, close to unity. Now let's come back to promised CO high northern hemisphere emission. This calculations, or using box model, resulted in the trend of CO between CO emission now in teragram per year between 2004 and 2020, more or less gradual. After that, the changes were very high for last 5 years. The MOPITT data also were processed by the same model, absolutely the same model, with different, slightly different correction factors derived from validation, and good, very good agreement with the Fed calculations. Now, the question, which part of the high northern hemisphere is responsible for this trend? The Fed allows to make calculations separately for these 4 areas: Canadian permafrost, Siberian permafrost, and 2 control boxes, and also here. Blue lines here are emissions in teragram per year. Blue lines here for permafrost area, and the last point is 2023. Red line is for control area that includes boreal forest of North America and South Canada. But no trend in boreal forest, and much lower values. For Siberia, very similar situation. Permafrost area demonstrate increasing trend, and no trend for boreal forest. What is the source of this CO for this permafrost area? What is the fuel for emissions? You see that this area, what this black and triangle CO emission is coincides with two huge coal basins, the largest in the world, Tunguska and Lena basins. Is it connected with emission of CO during fire or not? It is a question. Canada. For Canada, Alberta tar sands are in the center, the area of this oil sands in the center of the fire. It is a special month, 2023, July, the month of maximum burning. Discussion. The permafrost zone is partly covered by sparse forests, mainly larch in Siberia and spruce in Canada. The northern part of this area is represented by tundra and rocky desert in the highlands. The recent increase in fires in the subarctic permafrost region needs to be explained. Generally speaking, climate warming and dry weather are most likely explanation for that. However, the question arises, does the permafrost zone provide enough biomass for burning, especially for megafires in 2021 and 2023? What may be alternatives to such standard fuels as wood and peat? It is conceivable that thawing and subsequent drying of permafrost supplies fuel for wildfires. But option number 2, fossil carbons like coal, methane, oil, tar, and so on, should be seriously considered. Thank you for your attention.